Alright, welcome back. So, let's try integrating it and making our own logic behind our AI. So, the first thing we did was we had the path maker going through the line itself. So, if we were to remember, we had it create. I refactored it a bit, so now the render still stays rendering. The move object is now a specific function. Move along path is a specific function, and then we also have the current path position, which gives us where we stopped off last time, and then create is just procedurally creating and doing its own math and whatnot. So now we made all of these functions public, we can call it to another function, which is our shooter AI. So this function takes care of the pathing, this function takes care of the logic. So what we did different was we added a path maker, and then we added two more functions, which I am definitely going to create definitions for, meaning we got to make these functions soon. One is a rotate towards, the other one's a move towards, both using a vector3 and then the node pointer objective to the object to move. So this is going to take our logic of moving the object itself in our other abilities. Now the next thing we have is a path maker node. We changed our node pointer. Instead of having a component, we have a node pointer. It's going to call it off automatically. The next thing we did was we removed update and init inside our path maker. We left it like this, and then we gave our AI, so our enemy, the ability to bring the path maker inside so we can call it in our init function over here. Now one more thing we're going to do is we're going to init the path, because in our path maker we have something called init, so that will initialize it, create it, and do everything that we need it to do. Okay, the next thing we're going to do is, before we even start the state, is we're going to call on that main character that we had before. We had it easy. Now we're going to have to call it. So now we go into Unigine world, and then node by ID. So get node, we have the ability to get it by name, type, and ID. I'm going to be getting it by name because the name is the same as the name of the node pointer itself, and that just self-explanatorily connects it together. Alright, so now that we have it connected, we're gonna have to make our path maker and our functions and all that nitty gritty stuff. So the first thing we're going to do is we're going to keep these and we're just going to add new lines. So the first thing we're going to do is, let's say if the object, so if the Unigine math distance is greater than 0.1f. So what we're going to do is we're going to first check the distance between where we want to be. So in our object, our path, so on our path where we want to be, and where the object itself is, so the enemy itself, if it's greater than 0.1, if it's too far away, so node get world position, right, the distance between the node itself and the point, so path get current path position. If the distance is too far away, what we're going to do is we're going to let it move towards. So we do move towards, and then we're going to choose the position. So move towards the object and the object to move. So the object to move is our node, and move towards object would be the same path get current path position. Alright, and the next thing we're also going to do is rotate towards the path. So these are the two functions we created, and we're just going to do the same thing. Rotate towards object would be the same path, and then get current path position, so it rotates towards it, and then the object itself, and then we had a rotate speed, which I'm just going to do a 0.05 float, so it rotates at a 5 degree per tick. Or we could do by game.ifps, it doesn't really matter. Okay, so now that we rotate it, then the next logic would be like once we, so I'll put a space so we can know the difference. So once we get there, so let's say we get there, then we can do our path. So path, and then we go back into our functions. We had move along path and move object. So we're gonna first do move along path, which will move the point. So move along path, and then the next one is going to be path move object, and then it's going to ask for the object. We're going to say node, which is our object. All right, so now this is going to be doing it in its own time. All right, it's doing it, and the next thing we're going to do is then we catch somebody and we go into alert. Now for alert, we have many things we could do. For now, what we can do is when we're in alert, we could just say rotate towards the main character, get world position, all right, and then the object itself, and 0.005 f. I think 0.005 f would be fast enough, because 0.05 is pretty fast. This is like super fast. And yeah. Okay, so we're gonna move, we're gonna rotate towards it. All right, now if it gets caught, it goes into aggressive. In aggressive, what we're gonna do is we can do a move towards, and we can move towards the main character, get world position. So let's just say we're trying to hit us, and then the node, and then rotate towards main character, get world position, node, and 0.05 f. I'm just going to keep that 0.05 f, hold that and just press tab so we can see the difference. And then let's say we go back into search. What we're going to do is we're just going to rotate towards the character, and that's all we're going to do. So let's just make it that our character or our object doesn't really want to attack unless we're in his area. So the where he sees is his area. So think of it like that, right? And okay, I think that's a good enough logic. Let's actually consider that as our logic. Yeah, looks good. Okay, so the next thing we're going to do is actually connect the rotate towards and that. Normally we could do the world look at function, which is basically like node world look at, but there's no ability to make it slow or like, you know, affect the way it looks at something. So it's going to be looking at it in a very instantaneous way, and that's not what we want. We want the rotate speed to affect it. So what we're gonna do is we're just gonna write a few functions, math vector 3, right, and then I'm just gonna say vector a or 1, okay, and then we're just gonna use the object to move, so our node itself. All right, we're gonna get its world direction, and we're gonna get its forward direction. So math axis. Okay, and once we do that, that's cool enough. And vector 2 is our, so this is gonna be our rotating object. So the object that we're trying to look at, should have just called it looking object, but whatever. All right, so we're gonna do that. Oh, and since it's already vector 3, I don't have to do anything over here. We just minus it by our object to move the main position, world position. All right, so that gives us our vector, what do we call, subtraction. And once we have that vector subtraction, we can now normalize it. So that gives us a normalized vector, and then the other one's already a normalized vector. Okay, then after that, what we're going to do is we're going to try to find the angle between them. So we're going to do float angle equals to Unigine math, right? Get angle, and then it's going to get us an angle. So we're going to use vector 1, vector 2, and then we're going to use the up vector, which is going to be Unigine math vector 3 underscore up, right? And yeah, so that connects that connects that, and then that connects to that. Okay, so now that we got that done, then the last thing we're going to do is actually rotate our object. So object to move, right? Rotate, and then we're going to rotate it. So the main thing is our object is going to be tilted left and right, sideways, yawing and rowing and pitching. So what we're going to do is we're going to reset that. So we are going to just get our object to move, get world rotation dot x, and we're just going to negate it. So it just automatically turns straight or turns neutral rather than tilted. And then we're going to do that again. So object to move, get world rotation y, and then for this guy we're just going to do the angle, right? And then times it by the rotating speed. Alright, so now that connects our rotating forward thingy. The next thing we're going to do is actually trying to move it towards that object. So this one's going to be a simple lerp, to be honest. So we can do a Unigine, right? Then we could do a math, and then we could do a vector 3 position, and then we're just going to do a math lerp, right? And now we're going to lerp it between our numbers. So the first thing we're going to lerp it between is the object to move, right? Get world position. So we're going to lerp from the node towards the object we want to lerp to. So that's going to be move towards object, right? And then we're going to ask for a certain value, a percentage between 0 to 100%. How do we move it? So what we could do is we could lerp it towards the game's FPS divided by the distance it is. Now, as the distance gets closer, he gets a little faster. As the distance far, he's a little bit slow. But it's not too bad. I think it's more, what's it called, linear. This way it could be like equal. So if he's 8 distance away, so let's just do this. So Unigine math get IFPS. Oops, sorry. Game get IFPS, right? And then we could divide it by Unigine math distance, and then we could divide it by the distance between those two objects. So we could just copy and paste this. So copy this, paste it right here, remove that comma, and that should be perfect. Okay, and then once we have that, then we could just do our simple object to move. All right, set world position to be the position. Done. So what I was saying is our FPS gives us a consistent 1 per second, and if we have 8, if the distance 8 meters or 8 units, it's going to take us 8 seconds to get there. So it's going to be a consistent distance movement, and it's just going to work out. So let me see if I have missed out anything. At the moment, doesn't look like it. Only time could tell. Alright, so we're here. We got our little guy. He's gonna go inside. Now he's aggro. He's chasing me. He has that little rotation and he's coming close. I'm just gonna run away. And then as I try to run away, as you can see, that 0.05 is really scary. But now he's on search mode. He knows I'm in there, but he's not chasing me because I'm in his area. So now he's gonna go back to his point where he started, and then he's gonna continue his trial. So now let's just get back inside here. Okay, nothing happened. Now let's just get him in aggro. He's good. He's chasing me. He knows I'm there, but now he's searching. He's making sure I'm not in his line. And let's just go back inside. Now he's aggroing me. So now he's coming. All right, let's just get out of his search view. He's looking that I'm not too close to him, and then he goes back into where he was, and then back to his little path thing. Let's render that path. So okay, so now he's going back to his path. We stopped him, and now he's chasing us. As you can see, he's not tilted. He's still staying straight. We go back inside here. Let's check it out. He's going back to his position, and now look, he's tilted, and now he's straight up. He is now searching for us. Now, the way you make your character or the way you make your AI really depends on how good your coding is. In our case, he is definitely fast at looking, but once he's at search, he's not. Then he goes back to his position where he was, and then continues his patrolling. Now we could do that little jump thing, fix that, but for now, it's all good. Alright, so we managed to make our little AI. He has his own logic, he does what he needs to do, and now he has a whole AI controller input into him. So we can update this, or we can make more. Anyways, that's it for today. I will see you guys next time. Until then, goodbye.